In our previous Series 1 video, we introduced an Azure A2A multi-agent orchestrator that showcased multimodality and memory in a claims processing scenario. Now, we're pushing the boundaries further with a complex automated customer support workflow featuring MCP-connected remote agents, advanced orchestration and workflows, and human-in-the-loop capabilities, all working together to deliver intelligent, end-to-end customer experiences. Let's explore the multi-agent system we are going to design. As in our previous video, the host orchestrator remains the central hub for multi-agent coordination, memory, and workflow control. We'll connect several remote agents to assemble a collaborative team of agents capable of handling complex customer support scenarios, a legal agent for compliance workflows, a deep search agent for enterprise knowledge retrieval, a Google ADK sentiment agent deployed remotely on Google Cloud for real-time sentiment analysis, a classification and triage agent that can classify and automatically route customer inquiries, and a specialized customer support agent. Before diving into full orchestration, let's showcase the customer support agent as a standalone agent. This A2A compliant agent is powerful on its own. It performs ServiceNow actions via MCP, searches the web for real-time information, and is grounded in enterprise knowledge, guidelines, FAQs, and customer data, complete with human-in-the-loop decision points and coordinated automation. Let's see this in action. As you can see, this remote agent has its own user interface and can be interacted with directly. Now, let's step into the role of a customer service representative assisting Ana Lucia, who has reported a lost credit card. All of Ana Lucia's information is instantly available through MCP, giving us real-time visibility and full context to support her case. We start by asking about Ana Lucia's most urgent incidents. Using natural language, the agent queries ServiceNow through its MCP integration and identifies the top priority issue, a lost credit card. As a newly onboard representative, I might need guidance on how to handle this situation. So, we ask the agent to perform a knowledge search, retrieving the company's official policies and procedures. Based on this guidance, the agent advises us to freeze Ana Lucia's account and issue a replacement card. Once completed, we ask the agent to update the incident, automatically adjusting its priority to level 2, as outlined in the policy. All of this happens seamlessly through natural language, no manual navigation or ServiceNow access required. Let's verify in ServiceNow directly. Searching for the incident number confirms each action was performed successfully, demonstrating the agent's ServiceNow integration, knowledge-driven reasoning, and MCP interoperability. While powerful alone, this agent's capabilities expand exponentially when connected to a network of specialized agents. Together, they can reason, collaborate, and solve problems no single agent could handle. Let's see how this works in practice. Now, let's begin by assembling our team of expert agents. Here, we can browse the agent catalog, a global directory of registered agents, each with unique specialties and capabilities. We'll select our classification agent, deep knowledge search agent, Google sentiment agent, customer support agent, and legal specialist agent. Once registered, they appear in the sidebar, fully active and ready to collaborate. With our team assembled, the next step is to define how we want them to operate. This can easily be done by simply updating the host orchestrator's system prompt, no coding required. Any business user can naturally describe the workflow they want, and the orchestrator adapts instantly, shaping itself to fit any process, industry, or personality. This in itself is extremely powerful, an orchestrator that can be tailored in plain language, changing tone, role, and behavior dynamically. Our workflow runs in 2 distinct phases. Step 1. Context gathering and personalization. The agent analyzes user tone and sentiment, performs deep knowledge searches for relevant context, runs compliance checks against legal requirements, and pulls the customer profile from ServiceNow, including preferred language and any activity flags. It then creates a personalized, human-like response in the user's language and pauses for explicit confirmation. Step 2. Action and execution. When the user confirms, the system classifies the request, performs another knowledge search for supporting evidence, automatically creates a ServiceNow incident, and presents a friendly summary of what happened and which agents were involved. Now, let's simulate a real scenario. I'll log in as customer David Miller. David is now logged in as part of our human agent network, and we can see his profile card displayed alongside our remote agents. David then reports a fraudulent transaction on his credit card and needs assistance. Following the defined workflow, the orchestrator activates 4 remote agents in parallel: Google sentiment analysis to interpret the customer's tone, deep knowledge search to retrieve relevant policies, legal and compliance to verify regulatory requirements, and customer support, ServiceNow, to access account details and identify flagged transactions. As the agents go to work, their live status updates appear in the sidebar, with every action and reasoning step visualized in real time through the thinking box, giving the user full transparency into each decision, insight, and automated action as it happens. As agents work in parallel, they exchange structured context over A2A, allowing the orchestrator to aggregate findings into a unified response. The host agent then delivers a friendly, contextualized message back to David Miller, dynamically written in his primary language, French, showcasing how we personalize the experience. For demonstration purposes, we'll switch to English. This highlights the system's ability to adapt any workflow in real time and change the course of action even if we already have a predefined workflow. Here we can see all of our remote agents' responses, including data that confirms one potentially fraudulent transaction on David's credit card of $1,250. With our context established, we now move to step 2. The classification agent takes the lead, analyzing the case to determine its priority and risk level. In parallel, the deep knowledge agent retrieves the relevant fraud handling procedures to ensure the right actions are followed. Armed with this information, the customer support agent automatically creates a new incident in ServiceNow, with every field pre-populated, saving time and ensuring accuracy. Let's switch to ServiceNow to confirm the result. As you can see, the incident has been created successfully, and the description clearly states that the account must be frozen and a replacement card issued, perfectly aligned with compliance policy. Now, although this entire process can be fully automated, let's go one step further and demonstrate human-in-the-loop escalation. Our customer support agent isn't just an autonomous system, it's also human-capable. It can hand off tasks to a live customer representative when needed. Using the A2A protocol, we send an input_required task back to the remote agent, which automatically triggers a human escalation workflow. A2A knows how to handle this by design, pausing execution and waiting for the human's response before continuing. This makes it possible for any system, chatbot, or application to trigger human participation simply by catching that input_required state, enabling seamless human collaboration anywhere over any boundaries over the internet. Switching to our customer support agent's interface, the escalation request has been received. All conversation history, customer details, and context have been automatically transferred through the A2A payload. The MCP server adapts dynamically to David Miller's data, providing enhanced contextual visibility for the customer service representative to work with. The human agent reviews the incident, freezes David's account, and orders a new credit card. That update flows back through the A2A network to the host orchestrator, which marks the case resolved and closes the workflow. From detection to escalation, every step was traceable, context-aware, and adaptive, demonstrating how humans and agents work together across distributed systems in real time. In our next series, we'll showcase teams of humans and intelligent agents collaborating in real time, sharing context, coordinating actions, and making decisions together. You'll see how this hybrid network scales across industries, seamlessly blending automation, reasoning, and human expertise to deliver faster, smarter, and more personalized outcomes.